So hello everybody and welcome to our first ever virtual bash. I'm your host, Garth Gilmore. Just to make a few announcements before we begin. So announcement number one, injecting disinfectant is bad for you. Just say no, do not do it, okay? Number two, we plan to run these events monthly while social distancing remains in force. We have a theme and we have presenters for the next event. I just haven't told them yet. So there will be another event coming up in 3 weeks to a month or so, all being well. Announcement number three, first time we're doing this. The event is being recorded live and will be made available after via YouTube. There will probably be an awful lot of mistakes. So please bear with us as we make those mistakes and try and do the best we can. Questions can be asked via the Dev Bash channel on the NI Tech Slack. So if you haven't done already, please go over there. I will be looking at the questions as they're asked, and then I'll present a summary of those after each talk. So that's about it for me. Just to say thank you in advance to all of our speakers and to Ryan and Zara, who put in a tremendous amount of work to make this possible. Yeah. So what I would like to do is call on Marit to share her video and share her desktop, and let's make a start in.
All right. Thanks for having me. Let me share my screen. Yeah, there we go. So my name is Marit van Dijk. I'm from the Netherlands, and I'm here today to talk to you about collaborating on open source software and share with you a little bit of my experience in doing so. So first of all, I'd like to discuss the reasons why I started contributing, other reasons why you might want to contribute or might not want to contribute or might not be able to, different things that you can contribute, and then sort of how does it work to contribute and collaborate on open source. So the reason I got started with open source software is because I wanted to learn new things while doing something useful. I've been doing coding challenges for a while, and as fun as that is, it's not really part of a bigger project, and it's fun, but not necessarily always useful. Other reasons that people might contribute is to scratch an itch or fix something that they are having trouble with if you're using an open source project. I happen to know my friend Rien, who is doing a lot of the Cucumber JVM stuff. That's how he started. He wanted to fix one bug. Now he's pretty much maintaining the whole thing. It can help you build your resume or portfolio. It can help you build up a network. I got to meet lots of other Cucumber contributors and make friends with other people who contribute to open source. And there might be other reasons, in which case I'd love to hear what other reasons people have for contributing to open source. You can reach me on Twitter. My Twitter handle is in every slide. Of course, there are reasons not to contribute. It can be quite scary. You might feel you have nothing to contribute. There's a great talk by Eileen Uchitel that's on YouTube. I posted the link here. She did it at, she did this talk at We Are Developers in Vienna last year or the year before. And I really recommend it. She's a contributor to Ruby or Ruby on Rails. You might have other limitations. You might not have the time. I realize it's a privilege for me to have time to contribute to open source. You might have legal limitations in the sense that certain employment contracts might prohibit you from contributing intellectual property to open source. I'm fortunate that my current employer allows us to contribute. We have an open source addendum if we want to contribute to open source, and they allow us to do so. So if you want to contribute, make sure that you know about whether you can do so during work time or only on your own time, or your work machine, your own machine, etc. And unfortunately, there are people who had bad previous experiences. And I would really highly recommend finding a community that's welcoming and supportive. But there are many different ways that you can contribute. And I'd like to show you some of the ways that I did, and that might inspire you to do so as well. So first, you need to find a project, and a great tip is to contribute to a project that you actually use yourself, because you'll care about it and you'll already be somewhat familiar with how it works or how to use it, and might have ideas on what to fix or what to add. If you don't have such a project, there are lots of websites that will help you find projects or tasks to work on. And every October, GitHub has the Hacktoberfest, where you can get great swag like this t-shirt. This is my third one. If you get 4 pull requests accepted to projects. So my first project that I started contributing to was Cucumber. And I started with that because I just started using it early 2017, and I really liked it. And I was looking for a project to contribute to, so I started with that. And I have to say that I stayed because the community was very welcoming, and I'm very, very lucky to have stumbled into this community. When I first started, I made a mistake of merging something that shouldn't have been merged yet. And Aslak, who is the creator of Cucumber, and Björn were kind enough to help me fix that mistake. And I was mortified. I figured they want nothing to do with me anymore, and I should stop contributing. But they were very kind and very helpful. And I spent the entire weekend doing Git tutorials and am now the go-to Git person on my team. So that's pretty cool. And Rien on the right, he was very helpful in getting me started and finding issues that I could work on as a beginner. So the obvious thing that you can contribute is code. You can help fix bugs. And in fact, this is an example of, I think, my second contribution to Cucumber JVM, where I added some tests to reproduce an issue and then fix the issue. You can, of course, add new features. I have not done so, but maybe someday. But there are small things you can do, like refactor. This is a small example of changing some code from Java translated to Kotlin into more idiomatic Kotlin. You can add unit tests. In fact, my very first contribution to Cucumber JVM was adding a unit test to show that an issue had already been solved in the past. So I closed the issue just by adding a unit test to show it was closed. You can upgrade dependencies. For example, we use GraphQL in one of our projects at work. And I got a notice that there was a security vulnerability in one of the transitive dependencies that we got through GraphQL. So in the evening, I created some small pull requests to update that dependency so that we wouldn't get the old vulnerable version anymore. And you can help review PRs, which is also a great way to get more familiar with the project and learn. But there are also things that aren't code that you can contribute. And I really like this quote from the book Forge Your Future with Open Source by Vicky Brasseur. It says, "Please don't feel you have nothing to contribute to free and open source software if you aren't a programmer." And I'd love to show some examples of things that you can do. This is the book and a link to the book. I highly recommend it if you're interested in open source and the history of it and what to do and everything around it. So you can help the community. And one way that you can do so is by answering questions from other users. And there might be different channels to do so. Cucumber uses Slack, which is where I'm most active. And we also have Gitter and a mailing list. And other projects might have IRC or other ways of communicating. So answering questions can be very helpful, even if you cannot do any code contributions or whatever. You can help other users. And if you find that a certain question comes up often, you can consider adding that to the documentation or making sure that it's more clear. Documentation is often an example of where you can contribute. You can do so in many ways. You can add more information. For example, I was doing a Spring tutorial and found that one small step in the tutorial was missing. So I did a pull request to add that to the tutorial, figuring that the next person might also have the same question. I've added a bunch of stuff to the Cucumber documentation that wasn't there before. I've also edited and clarified a lot of the Cucumber documentation to make it less verbose, more clear, etc. Add examples, things like that. You can fix typos. I was playing around with PyTest, which is a mutation test library in Java, and found a typo in one of the error messages. So I fixed that because it's a small thing to do. Fix dead links in documentation. I found a dead link in the Docker documentation and fixed that. And you can review PRs on documentation as well, which is really, really helpful. Whenever I do a pull request on the Cucumber documentation, this person, whom I've never met in real life, will usually do a review very quickly and find like little things that I missed or small things that can be improved, making it that much better. And I really love that type of collaboration in making things better. And of course, you can provide feedback, especially the documentation for Cucumber that I've worked on a lot. I don't always know what's clear and what's not clear if you're a beginner. So providing feedback on, hey, this could be clearer, or I'm missing this information, is super useful because we don't always know anymore. You can help with issues. Reporting an issue can be super useful. Cucumber can be used in many ways with many other tools. We don't always use all of those combinations, so we might not be aware that there is an issue. But before you report an issue, please make sure to ask that it is in fact a bug or a feature that is desired. Make sure that it hasn't been reported before, and provide the relevant information. GitHub allows you to use templates, to provide a template with the information that you need. So if a project has a template, please make sure to fill that. And if a project doesn't have a template, you might want to add one. You might be asked to provide a minimal, complete, verifiable example, as described in the link on Stack Overflow, which means a small project that shows just your problem that you are having that will help analyze it. You can also help analyze the issues that are open. If you're having the same issue, maybe add some information on how to reproduce it, or add any other relevant information, or add a failing test. Even if you don't know how to fix it, adding a failing test might help get it fixed. Testing is still needed, especially make sure that a bug has been fixed properly, that a new feature does what it's supposed to, or even just try out a new release, which is what I try to do when there are new major Cucumber releases, is I will add them to our projects at work and make sure that everything continues to work as it should, and or let them know if it doesn't. And also testing documentation or tutorials. It can be helpful to have someone go through a tutorial and make sure everything is clear and the steps are in the right order, etc. And there are also lots of other things, like they might need design or front-end work. A friend of mine is a product owner for an open source project. There are lots of things that you can do. And if you don't know what you, with your background, can contribute, you can always ask the community. And if you don't have the time, please be aware that most projects do run on volunteers. Any open source stuff that I do on my own time. So at least be appreciative of those people and their time. And you might not be aware that it's possible for you or your employer to donate money to projects. And there are different ways that you can do that. Cucumber uses Open Collective, and there are some other ways that projects allow you to donate money. But also you should be aware that money isn't everything if the people aren't there to do the work. And there's a really good talk by Heather Miller on that particular point that she did for Lambda Days, and the link is here. So if you get started, we discussed finding a project. You need to check how to contribute to that project. And there are a few files to look for. Of course, the README, and there should be a contributing or hacking document that will tell you how to contribute. And there will be a license or a copying file that will tell you how you can use the project. There might be a code of conduct, which is especially important if you're not a white male. You might care more about how you are treated in the project, or if you're an ally, you might care about how people are treated in the project. There could be style guides to follow, and some projects will require you to sign a contributor license agreement, basically saying that you're allowed to donate your intellectual property to the open source project. But not all projects require you to do that. And again, if you don't know, ask. And if it's unclear, maybe add that information into a contributing document or whatever. So to pick a task, of course, you might have your own problem that you want to solve. But if you don't, you just like the project and you want to help out, then it's helpful to look for issues marked good first issue or something similar. or ask the community what you can do, because there might also be a lot of things that need doing that aren't necessarily registered as issues. So you might need to set up your environment with different tools like Git or another version control system, your programming environment, package managers. You might need Docker. And at some point you'll need to fork and clone the project. This is what that looks like on GitHub. And always make sure that you can build the project before making any changes, because if you cannot, you want to make sure whether you found it broken or you broke it. I recommend this for work projects as well. And if you cannot build the project, then maybe ask for more information. And if you can, add that information to the documentation, like the contributing doc. And next, if you have a task to work on, then collaborate with the people who are more familiar with the project. And I highly recommend discussing your intentions of, hey, I would like to pick up this issue, or I would like to add this feature to make sure that it's a feature that they do in fact want, or that your solution of how to fix it is in line with how they want to fix it. And to make sure that you're not spending a lot of time on something that they don't care about or that they might not accept in the end. So next, you'll work on your contribution. You can still communicate and ask questions if you have any. And at a certain point, hopefully you'll submit your contribution as a new pull request. It doesn't necessarily end there. You might receive feedback and need to iterate on it. And hopefully you'll get your contribution accepted. And this was the hooray for my first contribution that got accepted. You might get your contribution declined. And a famous quote for that one is, "No is temporary, yes is forever," by Jessie Frizzell. And she has written a great blog post from the maintainer perspective on always closing issues. That's really interesting to read. But if you communicated well with the project, then it should be accepted at some point, but do ask and communicate as you're working on your first PR. So hopefully I've shown you that contributing to open source doesn't have to take a lot of time or programming skill, because there are plenty of things that you can do that take a little amount of time or that are different skills than programming. And if you want to contribute but don't know how, then ask the community and look for a community that's welcoming your contribution. And please go forth and collaborate on open source. Thank you.
That was excellent. Thank you very much indeed. A couple of comments and quotes there. Awesome resources in the talk. You don't have to freeze the presentation afterwards. We will make the slides available. Yeah, so you'll be able to get them after the talk. Grand. Yeah. So then just to ask one question here. Let's say you're a benevolent dictator. You're one of the originators, of an open source project. What do you think are the most valuable things you can do to attract, contributors in, and maybe first-time contributors who don't have a lot of confidence?
Well, I can only speak from my experience, not being a benevolent dictator, but being a first-time contributor. And like I said, Aslak, who was the creator of Cucumber, was very welcoming and very helpful. Even though I made mistakes, he was still very kind and helpful and patient in helping me to fix that. Yep. So that I found that was really, really helpful. And, otherwise, if they'd been mean, I would have run off and maybe never, ever contributed to open source again. Yes. And another thing is Rien, whose screen handle is MP Korstanje. He was super helpful in helping me find good issues that were small enough to be good issues to start with. If you're unfamiliar with a big project, in the same way that a junior contributor on a work project might start with an easy issue on a project. And I've learned a lot from him in working with him, and he really helped me find issues that were good for me to start with. So I would recommend both of those things.
Excellent. Brilliant. Well, so thank you so much indeed. So at this point, I must banish you. So I must send you away. Yes.
Say goodbye. Thanks.
Thank you. Yep. And if I can invite Jamie to come on for the second talk. Hey, hi Jamie. Off you go.
Thanks very much. So my name's Jamie. Thanks for that intro. And this is my first time doing anything like this, so it's exciting. Today I'm going to talk a little bit about creating your own Kubernetes autoscaler. and a framework that I've been working on for the past 6 months or so to make that a bit easier. So first of all, just a little bit about me. I'm a final year computer science student at Queen's. I previously worked for a year on placement at IBM, where I was working on QRadar. While I was at IBM, I was given the task of open sourcing some internal projects and tool sets to put them out for third-party developers to use, and that kind of got me introduced to the idea of open source and some of the benefits of it. I'm constantly working on side projects. They're pretty much all useless, but they're all open source. I just fire them out there, great practice, just write something, put it out there, and someone might come along someday and find it. That's one of the great things I really like, is that if I make something that doesn't go in some dusty shed somewhere, someone might actually find it someday. That's quite nice. So that's enough about me. Not that interesting. I'm going to talk a little bit about the project. So my project is open source. I want to talk about some of the rationale behind why I open sourced it. So there's three main reasons. The first one is I wanted to build something that was actually useful and used by people. And I thought the best way of doing this would be to make it free and just put it out there. So someone can come along, find the project, and just start using it immediately. They don't have to contact me. They don't have to get me to set anything up for them. It's all just done for them. And this is really good. I really like this. The second reason is I want this project to be driven by user feedback and real life use cases. So having it as open source, I could get people to use it, come back to me, give me some feedback, tell me their use case, bugs, features, and this is really good. So I use GitHub for all this. So here's an example of a GitHub issue that's been raised where someone explains to me their use case and they say what they'd like, a new feature. And I celebrate every time a new issue is raised, even if it's a bug, it's great. And then the third reason is that Kubernetes itself is very open source friendly. It's the project itself is open source, and much of the major libraries that you'll use, such as Helm or Prometheus, they're all open source as well, and it's very open source friendly. So there's a big community in Kubernetes for open source projects. So I'm just going to talk a little bit about what Kubernetes is, what autoscaling is, and how it all works. So at its core, Kubernetes allows you to share resources between applications. So you might have 3 servers and 5 applications, and it means that you can run all 5 of those applications on those servers and share resources between them: CPU, memory, storage space, all kind of compute resources. And this is built on the concept of container technology. So you might have used that like Docker, and this is standardizing applications into units, and this allows you to kind of infinitely scale up and down. So Kubernetes allows you to assign more resources and less resources to different applications. So you might have an API that is very high traffic, and you want to give that more containers, more CPU, more memory, and you have one that's low traffic, you want to give that less. And this is kind of a balancing act. Autoscaling is the idea that this balancing act should be automated, and it should be based on real criteria, metrics, and should be just happen in the background, and shouldn't be someone going in, clicking a button saying, oh, put a new server in here. Kubernetes has an inbuilt way of doing this, and it's called the horizontal pod autoscaler, and it's really good. It is generally used to scale on CPU and memory, and for 90% of applications, this is all you need. CPU and memory is going to be a pretty good indicator of the kind of traffic that you're getting, either users or just requests to an API. But there is a bit of a problem, and this is kind of the 10% of applications that need something a little bit more complicated than that. So the horizontal pod autoscaler has a hard-coded equation baked into it that calculates how many replicas something should have. This can be augmented a wee bit by adding in custom metrics, and this will allow you to scale and kind of user-defined metrics, add stuff in, but you're still ultimately held back by this core algorithm. So if you need kind of more complex scaling logic, such as like conditional logic, queues, things like that, you basically need to write your own autoscaler, and this is really hard. This is really time consuming, and also you need to know a lot about Kubernetes, about its API, about the lifecycle, and how all that stuff works, even though your actual logic mightn't be relevant to that. So the goal for my project was to try and build something that allowed you to make your own autoscalers really quickly, really easily, and with quite limited Kubernetes knowledge. All that complicated API interaction should be all abstracted away, and you should be able to provide your own logic written in any language, framework, environment, and just supply that. And it should be really simple to use. your autoscaler logic should be simple enough to be put down into a single script that you can just interact with. So that's where my project comes in. It's called the Custom Pod Autoscaler Framework, and it allows you to write your own autoscaler in any language you want, in any environment. You provide your own logic written in, say, Python, Java, Go, any of those, and it will integrate in with this framework. The framework will manage calling your logic, collecting data from it, and then interacting with the API. This allows for really quick and easy development of autoscalers, fast prototyping, and it's really flexible. Any logic that can be started with just a shell command can be used. And there's a couple other key benefits. It all just runs in Kubernetes as a normal pod. You don't have to run it on a node or anything. And it's fully configurable. Everything that the horizontal pod autoscaler supports, this custom pod autoscaler framework supports as well. So you can have intervals, cooldowns, downscale stabilization, all of that can be configured. And another kind of added bonus benefit is this configuration. You don't need to do it on the master node. You don't need to have master node access. You can do it at build time, you can do it at deploy time, and this means you can use it on managed providers such as EKS or Google Cloud, which you couldn't really do with a horizontal pod autoscaler. You can't configure it on those managed providers. So I'm just going to talk through a little live demo and show you an example of a really simple autoscaler. It's kind of a little bit of a novelty one. Before I do that, I just want to explain two key abstractions that the custom pod autoscaler framework introduces. The first one is metric gathering, and this is your logic, your script, could be a Python script, anything, that will gather all the metrics and then we'll output them back in to the custom pod autoscaler framework. So it might reach out to an API, or it could just run some calculations. So the framework will then gather that and then feed it into the next abstraction, which is the evaluation stage. And this is like the brains of your autoscaler. And what this will do is it will take these metrics and it'll decide how many replicas should an application that it's being managed have. So I'll just show you a little example here. So this example is going to be an autoscaler based on Twitter activity. It's going to look for tweets with a certain hashtag, and it's going to look for and it's going to count the number of thumbs up and thumbs down in those tweets. And it's going to set the number of replicas to the thumbs up minus the thumbs down, the difference between them. So this isn't particularly useful, but it's just kind of showing the kind of arbitrary nature that you can have anything you want in it. So I've already got a cluster running here. So I've got two deployments here. One is the operator, and this manages our custom autoscalers. And we have this hello Kubernetes deployment, and that's going to be the application that we're going to scale up and down. So we also have our autoscaler running already. It's called scale on tweet, and this is just going to manage that hello Kubernetes application. So let's have a look at the pods at the minute. So at the minute, there's a pod for the operator, and then there's a single pod for the application that's running, this hello Kubernetes. And then we have our autoscaler here, scale on tweet. So let's put some tweets out and see if it scales okay. So we'll first of all put a tweet with a thumbs up with our hashtag custom pod autoscaler. And then we'll put out another tweet as well. So this is 2 thumbs up. So the autoscaler, what it's going to do is it's going to run every 5 seconds. It's going to get all those tweets, and it's going to count the number of thumbs up in those tweets. And then it's going to it should set the number of pods to 2 because there's 2 thumbs up. So let's have a look. It's not quite done yet. Joys of a live demo. So sometimes it takes a little while just to proliferate through the Twitter API. Okay, there we go. Phew. Right. There's 2 pods now. So it's successfully read those tweets, counted the thumbs up, and it's set it to 2 pods. So let's put in a third tweet with a thumbs up. There we go. So it should run every 5 seconds, and then it should change it up to 3 pods. Let's have a look. Still taking a couple seconds more. This is exciting. Edge of my seat. There we go. Container creating 3 pods. So now they're all running. So you can see it's counting up the thumbs up. So now we'll add in a thumbs down. So it should go down to two pods now once it's done. So let's have a look. So it'll take a while. It'll make sure that that pod's up. It'll run again and again, and it'll just count those number of tweets. Let's see. So there we go. One of the pods is now terminating again. So we'll be back down to 2 pods. So this is kind of a simple novelty example, but you can see how this could be expanded out into something that was actually looking at real Twitter data and using that to scale your applications. Any arbitrary source can be used. That's the kind of point I'm trying to make here. So I'm just going to show you a little bit of the code of how that works, and just I want to show you how simple this is and how it meets those goals. So this is our metric gathering script. This is going to be responsible for getting all the tweets and counting the number of thumbs up and thumbs down. So what this does is this just sets up our Twitter API, loads all that environment. This sets it all up, sets up the client, and then this gets all tweets with that hashtag that we put in. And then this goes through each tweet, counts the number of thumbs up, number of thumbs down, and then in this example, it's just putting it as JSON back into standard out. But you can do this in any format. It's up to you. You have complete control over all of this. So that's the entire metric gathering stage done. And now on to the evaluation abstraction. So what this stage does is it takes the metrics gathered by the previous stage and makes a decision, how many replicas should I have? So you can see some of the input that's been put into this. So you can see this is what a typical metric fed into it would look like from our metric gather, the number of thumbs up and the number of thumbs down. So this just reads in those metrics, it parses them into JSON, and then it only expects one metric, otherwise it'll fail. And then it just extracts out the number of thumbs up, the number of thumbs down, and then it calculates the number of replicas is the difference between them. And then it'll just output that back out again as these target replicas. And then the custom pod autoscaler framework will pick up and it'll scale to that amount. That's how simple it is. There's no complicated Kubernetes API interactions, anything like that. You don't have to worry about that. And there's a couple other files just to tie it all together. So this is a configuration file, and we just say where our scripts are, how we want to call them, timeouts, entry points. So these are Python scripts. And then there's a Docker file to just pull this all together. So this is based on a base image that I distribute, and it just adds in those files, adds in the configuration, and you can build this. And once you have this Docker image, you can just distribute this. Anyone can deploy it on their cluster as they want, easily enough, just fire it out there. And it's just all through normal Kubernetes YAML. So this is what a YAML file for the deployment would look like. So this is a custom pod autoscaler custom resource. And you can see that we're defining our image that we're going to use. That's the scale on tweet that we've just built. And then this is the application we're going to manage. So we could change it. We could change to a different application, easily done at deploy time. And then this is just some extra configuration options that we're injecting in when we're deploying it. So you can see that this is simple and you can configure it as much as you want. And I just want to get across that this is in any language. I've done this in Python, but you could do this in Go, you could do this in Java, you could do this in like .NET, anything that can just be started with a shell command and you can run in a Docker container. So let me just go back into here. So that was kind of a simple example, kind of a little bit novelty, but this framework can be used for more complicated autoscalers too. So this is one that I've built. This is a predictive autoscaler. So this is using statistical methods, models, and it couples that with the normal horizontal pod autoscaler, and it applies statistical methods, models to its output. So you can kind of predict things and build a kind of predictive model around this. So this is the horizontal pod autoscaler being re-implemented as a custom pod autoscaler with predictive elements put on top of it. So if we look at this example, this is a seasonal data model. So every day between 3 and 5 p.m., say, we have much more predictable, higher traffic consistently. So what we can do is we can apply this predictive autoscaler. It'll learn every day between 3 and 5 p.m. that there's going to be a spike in traffic, and it will preemptively scale to meet that demand. So if you look at these graphs, this is the normal horizontal pod autoscaler, and this is the predictive version. And you see these are the big peaks. So there's a peak early in the day and a peak later in the day. And these peaks are associated with big spikes in latency because the horizontal pod autoscaler is reacting to demand rather than predicting it. And this is after, I think, 2 days of gathering data. And you can see that these peaks have been greatly reduced because it's now predicting ahead of time and it's learning. So this is just an example of something you can do with the custom pod autoscaler framework. It's completely flexible, anything, and it abstracts away all the complicated stuff for you, and you can do it really quickly. And there's loads of other autoscalers. There's a locust pod autoscaler, which uses the locust Python framework for doing latency gathering, and you autoscale based on that. And you can use it for whatever you want. So that's kind of all I have to share with you today. Here's some maybe useful links that you might find handy. But yeah, any questions for me?
Cool. Jamie, thank you so much for a superb first presentation, and extra credit for doing a demo at the same time.
Yeah.
You know, very, very well done. Of course, this guarantees you get asked back now. You do know that, don't you?
Great. Exciting.
So just to ask about, you mentioned Locust there, which, if I understand right, is used for stress testing and, you know, bombarding applications with requests. So is that to then generate the load that the statistical model works off?
Yeah, exactly. So it uses that to do live Locust load testing on applications, and then it will scale based on that. So say you have lower latency, it might need less pods, or if you have higher latency, you probably want to put more pods in, something like that. But just basically those ones I've made, but it's completely flexible. You can do whatever you want with it. Like, anyone can make anything. It's great.
Excellent. Brilliant. So thank you so much indeed. So if
Thanks
I can dismiss you now magically, yeah, and if I can call on Jason for our third talk.
Hello. Good afternoon. Right. Okay, so thank you for having me. Two excellent talks so far. Thank you for those. They were brilliant. I'd like to do an introduction to Kafka. I get asked about this a lot, so I thought I'd do a very quick run through. So first of all, I'm currently with a company called Digitalis, which do managed services for Cassandra and Kafka and Postgres. And also we have a product called AxonOps, which is a Cassandra monitoring tool, which is fabulous. For those that don't know, I have written a book. This is the second edition now, the machine learning book that I've got. And while this is the first virtual talk I've done, the rules still apply. You can still heckle on Twitter, as far as I'm concerned. There's no problem here. It's Friday, so please go ahead. Okay, so what is Kafka? It's a mutable log. It's a message log system. That's really the simple answer. Okay, so when we have a log of messages, they're written in order, and those messages are consumed. So think of it like this. It's like a cassette tape that runs. I do have an opinionated thought about Kafka. This is just my thought. It is not a database. Just my opinion. Others may differ. That's fine. To me, Kafka is an event processing system, which is based on distributed architectures, which means we can have many machines running, processing those messages. From the applications that access Kafka, it just thinks it's one big processing system. It's not interested in the number of brokers and nodes that are running. It will just send messages and consume messages. But what that does give us is a system that can handle millions of messages. It's fault tolerant. It's incredibly fast when it's tuned properly as well. So, like I just said, we've got producers that would send messages. They go into the Kafka cluster, which is a bunch of machines, and those messages are consumed by consumers. And what I'm going to do is I'm going to go through each of those sections and talk about some other bits of the cluster and the framework as well. Messages are sent to topics, so you can have many topics, and you can subscribe to specific topics and consume from those, or if you're really brave, you could consume to everything. I've never seen that actually done before though. Kafka operates on a replicated architecture, like I've already said, and those messages are also partitioned, which means you've got a good amount of resilience if brokers go down. So if brokers go down, at least you know messages are going to be held in another broker somewhere as well. Once records are appended to the log, they can't be amended or deleted. It's an immutable log. The reason I say this is because sometimes people ask me to replay messages from the start, and then I have to politely tell them that they're not there anymore because of the way that offsets in the message logs are handled. And I'll talk about that a little bit later on. Each message is essentially a byte array. These are serialized and deserialized in various means. Each message has a key, a value, which is actual payload, a timestamp when it was sent, and there's also header information as well. Earlier versions of Kafka just had the payload and nothing else. And as the framework has developed over the years, these things have been added to them. So now we have a fairly comprehensive messaging system. Serialization is done on producer and consumer side. I will go into a bit more detail about that shortly. Okay, so let's take a look at the ecosystem itself. There's three parts to it. So there's the Apache part, which comprises of Apache Kafka itself, the Kafka Streams API, Kafka Connect, and the Kafka clients. And these are the parts that I'm actually going to talk about in this talk. I'm going to leave alone the Confluent parts. As they're not part of the Apache distribution. If you download the Confluent community license, then you have access to the other tools. They're all very good, but that's not what I'm going to cover here. So looking at the cluster itself, we've already talked about brokers. A single broker is a machine. It's a node of a machine. And we write to topics, and the topics can have a number of partitions. So if I was running this on a standalone machine, for example, it would just be a single broker, and I would just be creating single partition topics. And they run quite merrily if you're not handling too much load. But obviously, the more data we want to start throwing at it, we want some resilience there. So we can start adding more machines in. And therefore, we want to actually start increasing the number of partitions that we're using as well. So what we are ending up with here is a 4-broker system, which is 4 machines. There's a designated leader partition. So when a message is written, it goes to the leader partition first, and then it's replicated out to the other partitions, which are called the followers. So what we end up with is resilience across all the brokers of a message that enters the system. It's the producer that produces the messages and sends them to the leader. So the partitions are the log themselves with the messages. But when we start adding partitions, we have duplicates of messages, and it may not be completely balanced. Some messages may have more than others. What would happen is if it becomes too imbalanced, Kafka itself will automatically rebalance the cluster for you, which means that you get a good balanced throughput of messages against consumers. But we'll talk about more of that shortly. Topics. We create topics, and I'd still do this in the command line. So the Kafka distribution has a full bin directory of shell commands to create and maintain the cluster. Okay, so to create a topic, I'm using the Kafka topics shell command. The flags that you can see here, so we're creating a topic. Zookeeper is used for topic metadata and also to designate which which broker, sorry, is the leader. So we need to be able to have access to the Zookeeper cluster. I'm using a replication factor. Using a replication factor there of. I can't actually see it because my face is in the way. And the number of partitions that I want to assign to that topic as well. Then we give the topic name. And the additional configuration at the end is the number of replicas that I'd like to write to before my message is classed as correctly written. So in this case, it's 2. So I'm going to write to 2 brokers, then I definitely know that my message is written correctly. This can be increased to the total number of brokers, but 2 is a good number to start off with. To list topics, it's the same command, but just with the list flag at the end. And there's an option to delete topics. But when you delete a topic, it will say it's marked for deletion. But if the broker settings are set with delete.topic.enable as false, then obviously the it's set to true. Then the topic will be deleted. Otherwise, it will still continue to be operational. Retention. So Kafka operates retention policies on messages. The default is 7 days. So you have 168 hours if the setting isn't actually set up. You can configure this by either hours, minutes, or milliseconds. The smallest value takes priority. So if you have log retention hours set to 168 and then also have log retention milliseconds set to 1 second, 1,000 milliseconds, then your messages will last 1,000 milliseconds, and then the offset will be moved forward and you won't have access to those messages. So always keep that in mind. Ideally, just set one type. I always use milliseconds. Then you know where you stand. If you start mixing them up, it can get quite confusing. You can also do retention by size. So if your log is set to a gigabyte, anything over a gigabyte in the log file will be not available to you. This is based on the number of partitions. So if you have 8 partitions, for example, then you'll be retaining 8 gigabytes of data. It's worth noting on that one. It has caught people out before. It also means you need to make sure that the capacity of your nodes is sufficient enough for the amount of log retention that you want as well. Kafka operates a number of client libraries. It was originally written in Scala and Java. It's more moving over to the Java side than anything else. The Java libraries are fully supported for all the aspects of Kafka. You would need to check on the other ones depending on what language that you want to use. So for example, on the Go side, things like exactly on semantics, the Kafka streams, scheme registry aren't supported, or at time of when I originally wrote this slide, which was probably last October now, they weren't supported, but it's worth checking to see what features are working with the client libraries that you're wishing to use. So let's move on to producers, things that actually produce the messages. The actual operation, calling these APIs is quite simple. It's define the properties of the cluster that you want to talk to, and then write a message. So as you can see there, the properties section sets up everything we need to know. So we say where our cluster is with a bootstrap service setting, whether I want an acknowledgement that my message has been sent. I'm going to talk about that in a bit. the number of retries to do if there's a problem. I'll talk about that element as well. I'm batching these messages up and sending 10 at a time. And the final couple of parts there are the serializer classes that I'm using for the key and for the value. And I'm just using strings for this one. I then set up my producer, and then I'm just looping through 10 times to send a number of messages. The main thing there is the producer.send method, and that just sends the record through to the brokers. And that's essentially all it takes to write a message to Kafka. The acknowledgements, I've got it set to all. So what this means is that the message is sent to the leader and also all the followers. And once that's happened successfully, the acknowledgement will be sent back to the producer and be told everything's fine. The message has been sent and it's reached everywhere we're expecting. There are two other settings for that. 0 is just a fire and forget. The message is sent and we're not expecting anything back from the brokers. If it's set to 1, then it's only acknowledged when it's successfully sent to the leader, and we work on the assumption that the message is being sent to the followers without any issues. If the messages are very important to you, then the desired effect really is to go for ACS equals all, and just be sure that the message is being written to all the partitions that you're expecting it to. If you are really interested in your acknowledgements and making sure everything has worked, you can use the producer interceptor, and that will override some methods to say whether your what happens, on the sending of your message, and also on the acknowledgement that the brokers have received the message based on the ACK setting that you have. It's worthwhile doing that. It means you can count the number of messages that have been sent. While you can do that through monitoring with JMX, it's sometimes handy just to have your own system there of recording the number that you've actually sent, so you can then tally that up with the consumer side if needs be. The retries, on this example, it's set to 0. You can set it to a number if the producer cannot reach the brokers. If the retries was 0, it would just throw an exception and fail. With retries greater than 0, we're then into some kind of retry policy where there's a timeout, and we're backing off for a certain amount of time. So in this example, we've got a retries. We're going to do 3 retries if we can't hit the brokers properly, and we'll time out after 15 seconds. And for each retry, we're backing off 1,000 milliseconds, which is 1 second, obviously. The thing to keep in mind with retries is if the message ordering is important to you, then it's worth setting the maximum flight requests to 1, and then the messages will be sent in the order that they were created. This may not be completely important to some people. If you're still sending in batches, then that's perfectly fine. If 1-by-1 messaging is important to you, it may be an event sourcing system, then the maximum flight message request is going to be important to you, especially on the retry policy. The serializers, there are a number of different ones available. I've just used the string ones here, but you can convert your messaging keys into pretty much anything you want to. You can also write custom serializers. The SerDes ones are the default ones, and there is a JSON serializer and deserializer available to you as well, which is especially handy on payloads. So now we've written messages to Kafka with the producers, let's have a quick look at the consumers. Once again, the APIs are rather constructed in such a way they're nice and simple to use. Once again, we're starting with a set of properties just to say where the cluster is. This time we're working with consumer groups. So I've got a group ID there called test. We're automatically committing our offset, which I will talk about shortly. And once again, you can see the deserializer this time, which is the string deserializer, to convert the message key and values as they're consumed. I'm sending an array of topic names. I may want to keep an eye on more than one. In this instance, I'm only looking at the one topic that's sent in via the command line. And after that, it's just a simple while loop to poll the brokers for new records and pull them in, and then work through each record and deal with the content. There is a setting available to you that if the consumer doesn't do any processing for a certain amount of time, it will then close down and the consumer will then leave the cluster. This may trigger a rebalance of the cluster, which Kafka will do itself. So it's something to keep in mind about the volume of messages that you're sending through and how you wish to consume them. So that's a very basic consumer. They are expanded on a little bit. Consumer groups are important because it gives us the indication of where we are. You can have any number of consumer groups, and they may use the same consumer code. So we can keep things processed in different groups. And it also means that we can have any number of consumer clients running within a consumer group, which will increase the throughput of your consumers and the messages going through. It will take some tuning and experimentation to find out the sweet spot of what the consumer processing is. So you may have a 4-partitioned topic. You can still have one consumer group running, and it will consume the messages as quickly as it can, but that's really not operating in a fully distributed and probably the best way. The idea would be then to try and have at least 3 or 4 consumers running on the same consumer group name to process in parallel those messages coming from the topic partitions themselves. And at that point, you'll see a huge difference of performance and throughput. So consumer group offsets is really just a simple number that says this is the message position that we're at. And we can find out where we are in the consumer group by running consumer group commands. So we can describe a group, and it will tell us the offset position of the each of the partitions, for example. And it also tells the lag, which is how many messages that the consumer group's behind, which is really helpful because at this point we can actually see when a cluster's imbalanced. So for this example, yeah, the current offset is where my consumer is, which is the first is record number 1, is consumer record 0. The log end offset is the current maximum offset position, the latest record, which is number 12. So obviously there I've got a lag of 11 messages that I've not read yet. Obviously this number goes down just as your consumer messages, and you're polling any number of messages at a time. But it's a good metric to keep an eye on. And this is also available through the JMX metrics. There's a log offset start and a log offset end JMX metric. So you can see on a consumer group level in fairly much real time where the offset position is that you're working with. There are other APIs available within Kafka. The streaming API is both a consumer and a producer. So what the streaming API will do is consume from a topic and then allow you to be able to do either transformations on that data, or if it's numerical data, for example, you can then do aggregations and sliding and fixed window functions and redirect these results to new topics. There was a time when we used streaming API to be able to do things like persist data to a database, or to S3 buckets, for example, just to output messages to text files. That's kind of been replaced now with Kafka Connect, which I'll talk about shortly. I've got a streaming word count example here because it's just nice and simple. So the example here would be that each message value is just a sentence of words. and the mapping of the stream will then go and count the words for us. It just flat maps the values and then does a count on each word on a group by, and then pushes the value of that back out to a new topic. So over time, as the as sentences are sent via producer, the word count would increase, obviously, and that increasing number will be sent out as a new message to the topic. This really becomes powerful when we're doing aggregations. So you may have a key of a customer ID, and for every time that they're adding something to a shopping basket, the total is being added up, and the total is then being sent to a new topic, for example. For a fuller explanation of the API, the best one I've seen is still written by Jay Krebs, which was one of the original Kafka streaming blog posts. It's quite long, but it's very rich. It's worth a read. So Kafka Streams is the only part of the API that supports exactly once transactions. And I know what you're thinking whenever you hear exactly once transactions, but it does actually work. So if the processing guarantee within the setup properties file is exactly once, then that is what Kafka Streams will do. It will process it exactly once. Kafka Connect is another consumer and producer application. And what this now enables us to do is read data from sources and also persist data to sinks. This means that we can do things like read from databases or a Twitter stream or Logstash, for example, and write that data out as topic messages, and then they're sent to the brokers. On the other side of that are sinks, and that's reading from the topics and then persisting that message data to another endpoint. It may be a REST endpoint, it could be a database, it could just be persisting a file to S3, or it could be Elasticsearch, for example. There are loads of connectors available now, and it is worth checking whether the plugin actually exists first before you go trying to write your own. The framework for writing your own is very good, and I've written a couple myself now for various things within Digitalis. But where possible, I still think it's the path of least resistance works best, and to go and look for a plugin that actually fits your needs first. So to look at a source example, Twitter. The Twitter plugin exists on GitHub. This is just, and it's configuration. It's nothing more than that. Once the jar file is in the same class path of Kafka, then you have access to it through the Kafka Connect API. The configuration for these workers is just in JSON. And depending on what the plugin is, really depends on the values that we need to give it. So in this Twitter example, for example, we need to give it the access token and the consumer secret key and the secrets. We need to say what filter words that we're working with to send, which is essentially a Twitter streaming API job. And then also what topic we want to send it to. So what happens on this example is that when tweets are found via the Twitter streaming API, they are sent to the topic as their full JSON representation. So what would normally happen there is we'd do some transformation on the JSON. That might be a streaming API job, or it may not be. It may be through, if we're using Confluent, it might be through KSQL. And then the resulting data is sent on to the brokers, for example. To deploy those, we can do that through curl. There is a REST API for Kafka Connect, which looks after the plugins and all the connectors that are installed there. So all I'm doing, it's just a post as a JSON application type, and I'm saying what my JSON configuration is and just sending it to that endpoint, which is localhost.8083/connectors. That will install the connector and attempt to execute it. If there's a problem, then it will fail and it's worth keeping an eye on the logs at that point to see when connectors fail. There's an awful lot of output, so sometimes it's difficult to track, but you can also, with that REST API, look at the status of each of the connectors. It's worth looking at. It's excellent. The sync example is exactly the same. It's JSON configuration, but this time we're saying, in this example, we're taking messages from a topic and then writing them out to a database. And it's just, all we need to do is give it the driver details and what the connection strings. In this example, my payload is an Avro encoded payload. Therefore, I need to give it a schema registry to decode and confirm that the schema for that Avro payload is correct. If the schema is correct, then the message will be processed. And if it isn't, it will then be sent on to a dead letter queue, which I'm going to discuss now. So dead letter queues are topics that exist for messages that haven't been processed properly. They crop up in two places. Dead letter queues either end up being used within the streaming API applications or in Kafka Connect. And this is because what we want is these applications to continue running, and we don't want them to fall over when bad messages come in. But we do want to know what bad messages have been sent so we can then go and inspect them and deal with them afterwards. Sometimes stuff just doesn't work. So Kafka Connect would read, keeping with our sync example, would read from a source topic. And if the message didn't conform in the conversion, it would then be sent to a dead letter queue. If it was fine, then we'd process it and with our sync plugin and persist it as usual. So our dead letter queue, though, needs some form of setting up. So within the configuration JSON of the connector, for example, in Kafka Connect, we say what our dead letter queue topic name is going to be, because it's another topic.
Listen, sorry, just have to break in because we've gone a little bit over time. So,
oh, sorry.
Yeah, it's okay. Can I just give you like a couple of minutes to finish?
Sure, I'm nearly done.
Sorry?
I'm very nearly done. Okay,
cool.
Sorry. I was getting far too excited. So just to wrap up here, the dead letter queue name, we've got a replication factor because it's just another topic. Now the error tolerance is all, which means this plugin will continue running even when the messages have been processed. So if there's an erroneous message, the plugin will continue as is and just send the message to the dead letter queue. If it was set to none, the plugin would stop and then we could just go and investigate what was happening. We can also send log information and other bits of metadata through to the dead letter queue as well. And we can also send the exception log through so we can see what happened with that message at the same time. And that's really it. After that, monitoring. So JMX is supported through every part of this for the ecosystem. So the brokers, consumer producers, Kafka Connect, the streaming API all have their own sets of JMX. It's an awful lot of data to consume, so I would strongly suggest that you use something like Prometheus and the Java agent to consume the metrics so you can look at them as the cluster's running. And you can use JConsole for picking up those metrics as well and seeing what's actually going on. And I think that's it. Yes, that's me. I'm finished. Thank you. Sorry, I ran over.
You're okay. That was incredibly entertaining. Thank you so much. I now know what Kafka is. Yes. So just to ask one question. What is the volume of requests or the main use case? You know, what's the trigger that would drive you to use Kafka over a more kind of traditional enterprise messaging system?
So the original design of Kafka was for logging and for log messages, but I've seen it used. I've used it a lot with things like decoupling message events from websites, for example. So things like confirmation emails and stuff like that. SMS messaging, any form of messaging that you can send down the wire. Mm-hmm. Basically, you could then fan out to, might be an SMS message, it might be an email you have to send, it might be, those kinds of triggers are perfect use cases. And other transactional type of data, CQRS systems as well.
Yeah.
So command and action control. Yeah, there are thousands of use cases now where Kafka really holds up well.
Excellent. And another question there, if you were being very on trend and trying to do an event sourcing architecture, would Kafka be a good choice there?
Absolutely, yes.
Excellent.
Yeah, I've seen a couple of these being rolled out, and they're very good.
Excellent. Very good. Well, listen, thank you so much. If I can just ask all the presenters to come back on, and Ryan and Zara as well, who put a huge amount of effort into organizing this. Excellent. So listen, thank you very much indeed. Thank you very much to everybody who attended, and we will be doing this again. So please stay tuned to the Twitter feed and the meetup page. Thank you so much, guys. Cheers.
Thanks.
Bye.
Thank you.